Hello, everyone. This video will introduce us to the two identity rules. The first one is identity introduction. It's displayed there on the left. And the other one is identity elimination. There are two versions of identity elimination, and they're displayed there on the right. Identity introduction is very easy to apply. It's an inference rule that takes no other lines as input. So anywhere in your proof, anywhere along any scope line, you can simply introduce a universal generalization of the form that you see there. So for all x, x equals x. You can do so with any of the variables w, x, y, or z. This statement effectively says everything is self-identical. So when you cite identity introduction, all you need to do is write down the name of the rule. You don't need to write down any line numbers. Let's see how identity introduction works in a simple proof. There we have a proof set up. This statement is simply to be read, there is a y such that b is identical with y. I'm going to do this proof in honor of my undergraduate logic professor. His name was Botkin. That's what the B stands for. This was his way of translating the statement, Botkin exists. So Botkin is identical with something, or there is something identical with Botkin. This statement's a theorem. So I have it along the main scope line at the bottom, and we're going to derive this statement from no other primary assumptions. The way we're going to get started right there on line 1 is by appeal to the rule identity introduction. So I just insert the line for all x, x equals x. The next step in the proof is to simply instantiate the universal generalization on line 1 to any name we like, but obviously, if we're going to derive there is a y, b equals y, we need to instantiate to the name b. That comes from line 1, universal elimination. And then our proof finishes there on line 3 with an application of existential introduction to line 2. What we see here is that this derivation, this proof of this theorem, has no primary assumptions, obviously, but it also didn't have any subderivations. Up until this point, if we wanted to prove a theorem, we had to begin on the first line with a subderivation. What identity introduction allows us to do is just start a proof of a theorem right there on line 1 along the main scope line by appeal to identity introduction. And in fact, identity introduction is most useful in proving theorems. It turns out to not be a terrifically useful rule, but there are some theorems that it can be very useful in proving. Okay, so now we're going to take a look at the second identity rule, identity elimination. There are two statements of identity elimination. We'll just look at the one on the left first. The one on the right is basically the same. So what we see is that the first item of input for identity elimination is an identity statement. It looks a little strange to have these T's here on either side of the identity, T1 and T2. Those stand for closed terms. It's a technical term used in the book because this chapter introduces function names, which we aren't working with. So you can just think of this as an identity with any two simple names on either side of it. The second part of the input for identity elimination is some statement of the language that has, this is implicit, it has one of these two names in it. Okay, so we always see here is a capital P, but it's supposed to stand for any sentence that has one of the names in it. And then what we get for output is a substitution of one name for the other. So if this had the name T2 in it, we can take T2 out and replace it with T1. And the double slashes here indicate that you don't have to replace all occurrences of T2, you can just replace some of them. The right-hand statement is pretty much the same, except it says that if your sentence has the name T1 in it, then you can take any number of the occurrences of T1 out and substitute T2 in for it. Another name for identity elimination is the substitutivity of identity. Okay, so it basically means once you have an identity statement linking two names, then you can substitute any of those names for one for the other. I will point out that you should think of the input for these inference rule identity elimination in a certain way. So you do have to have the identity, and that identity justifies substitution. Okay, so we always have to have an identity justifying substitution. And then we also have to have a context for substitution. And of course, what's going to be a context for substitution would be any sentence that has one of these names in it. Okay, if it doesn't have one of those names in it, it's just not a context for substitution. So whenever you're applying identity elimination, you don't need to make this clear in your annotation, but it needs to be clear in your own mind which statement is the identity justifying substitution and which statement is the context for substitution. That's not always easy to separate because sometimes the context for substitution is itself an identity statement, and things can become complicated there in terms of how the rule applies. So let's take a look at how identity elimination applies in some simple examples. Okay, here's our little proof. We're going to derive the statement A is identical with D from these primary assumptions. A is identical with B is identical with C, and D is identical with C. The first step we're going to take is, not surprisingly, an application of our new inference rule, identity elimination. And we're going to get A equals C from lines 1 and 2, identity elimination. And I want to pause there and sort of focus in on this. We have two identity statements. One of them must be the justifier, the identity justifying substitution, and the other one has to be the context for substitution. And in this situation, in this particular instance, it doesn't matter which. So we can think of ourselves as taking B out of line 1 and substituting C in for it because we're justified by line 2 to do that. In that case, line 1 would be the context for substitution, and 2 would be the context for substitution. However, we can equally think of ourselves as taking B out of line 2 and substituting A for it, because line 1 justifies us in substituting A's for B's. In that case, line 2 would be the context for substitution, and line 1 would be the identity justifying substitution. So however we think of it, line 4 comes from lines 1 and 2 by identity elimination. And then in the next step, which is the last step, we can cite lines 3 and 4 identity elimination. Here we don't have the same kind of latitude. Line 5 has to come from 3 and 4, where 4 is the context for substitution, and line 3 is the identity justifying substitution. There's no way of those two line numbers reversing roles. So on line 5, what we've done is we've taken C out of line 4 and put D in for it. We're justified in substituting a D for a C thanks to line 3. So line 3 is the identity justifying. It's our justifier. And line 4 is our context for substitution. And there's no other way to do it. In this derivation, we're going to derive the statement LLS. This might say Lois loves Superman from these three primary assumptions. LLL, Lois loves Lois. Premise 2, C equals S, maybe this is Clark is identical with Superman. And then premise 3, little plot twist, Clark is identical with Lois. Now there's a number of ways of getting to the target statement, even in this simple little proof, but one thing we can do is certainly to start with this identity that we can derive from 2 and 3 together. So it might be a statement like Lois is identical with Superman. That comes from 2 and 3, identity elimination. Why don't you pause and think for a moment about which identity is the identity justifying substitution and which is the identity that provides the context for substitution, or does it matter? Go ahead and hit pause and think about that before resuming the video. In this case, there's no way around it. Line 2 has to be the context for substitution, and then line 3 is the identity justifying substitution. That's because C is taken out of line 2 and L is substituted for it. And we're justified in substituting L's for C's by line 3. And there's no way to get L is identical with S by treating line 2 as the justifier and line 3 as the context. Why don't you make sure that you understand why that's so? On line 5, we can get our target statement, LLS, and this highlights one of the interesting features of our identity elimination rule. This comes from lines 1 and 4, identity elimination. So what's happened is we've taken only one of the names, L, it's the second one, out of line 1, and we've substituted S for it, and we're justified in doing that because L is identical with S. Notice we didn't replace all occurrences of the name L with S. We only replaced the second one. So we've taken the second L out of line 1, and we put an S in for it, which we're justified in doing by the identity. And the result is LLS, Lois loves Superman.